Hello, this is Mr. Best. Welcome to Chapter 8, Polygons and Circles, homework questions 116 to 122. This is day 1 of Lesson 8.33. Question 116. Use what you know about the area and circumference of circles to answer the questions below. Show all your work. Leave answers in terms of pi. So, first one. If the radius of a circle is 14 units, what is the circumference and what is the area? So, quick reminder that the area is pi r squared, and the circumference is 2 pi r. So here we go. Area, we have pi r squared, or pi times the radius, which is 14 squared. So therefore, if we're leaving in terms of pi, that's 196 pi, and then that would be units squared. The circumference is equal to 2 times pi times the radius, so in this case it is 14. And since, once again, we're leaving in terms of pi, that would be 28 pi units. So those are the exact answers. If we wanted the approximations, we'd have to plug pi into our calculator and use the calculator button pi. Don't approximate 3.14. Use the actual button so we can get the most accurate answer when it asks for it. So let's see, on the next one, B, if the circle has a diameter of 10, what is its circumference and what is the area? Well, the diameter is now 10, so that means that the radius is half that, which is 5. So let's go ahead and work that. Area equals pi times 5 squared. So therefore the area on this one is 25 pi, once again units squared. And then the circumference is 2 times pi times r. Now, the circumference also could be written, because it's 2 pi r, 2 times r is the diameter. So we could also technically write the circumference as pi times the diameter. So if you wanted to do it that way, that works as well, and then that way you don't necessarily have to take half of the 10, but the math either way is not too challenging, hopefully. So let's see what we get. Circumference is 10 pi, and that's 10 pi units. All right, so I think we're good there. Let's move on to C. If the circle has a circumference of 100 pi units, what is its area? So circumference is equal to 2 pi r. So if 2 pi r is equal to 100 pi, we can kind of set up an equation here just saying that those two things are equivalent. If you divide by pi, that will cancel, and that will cancel. So that just means 2 times the radius is 100, so therefore r is equal to 50. That's one way to do it. There's other ways to kind of look at it as well, but that's one way. And so now that I know the radius, then I can find the area by taking pi times the radius squared. So for this one, that will give us an area of 2,500 pi, and then once again, units squared. And then the last one, we have D. If a circle has a circumference C, what is the area in terms of C? So I'm going to move that up a little bit. So we know that the circumference is going to be labeled as C. So we're just going to say that the circumference is actually equal to C. We also know that C is equal to 2 pi r. So what is the area in terms of the circumference? Well, area is pi r squared. So we need to get r in terms of the circumference. So we can do that by dividing by 2 pi. So r is equal to the circumference divided by 2 pi, and then we can basically just do substitution. Pi times the radius, which in terms of the circumference is circumference divided by 2 pi, and that is squared. And so when we look at this, we can simplify this a little bit, because we can square, we still have the pi, but we can square the circumference, and we can square the 2 pi, which would be 4 pi squared. And then we also have so we can also write this. So this is pi over 1. So I'm going to write this out so you can see pi times the circumference squared over 4 pi squared. Now that's almost it, but we actually have, because there's a pi in common, we can cancel pi divided by pi, but that still leaves 1 on the bottom. So at the end, let's rewrite this. The area in terms of the circumference would be the circumference squared divided by 4 pi. Now, that's not a formula that you need to go and now memorize so that if you have the circumference, you can find the area. but it's just another way to kind of think about what information that you have and what you can still find. Question 117. In 2000, a share of Jiffy stock was worth $20, and in 2010, it was worth $50. What was the annual multiplier and the annual percent of increase? So in the year 2000, which we'll just say is at time 0, the stock was worth $20. In 2010, which would be at time 10, the stock was worth $50. All right, so we're trying to figure out what the multiplier is. So it's getting multiplied each time, but it's getting multiplied in between 0 and 10. So, times b, and it's going to keep doing this 10 times. So the equation that you could set up would be 20 times b to the 10th power, because you're going to have to do it 10 times because there's a difference of 10 here, should be equal to 50. What number would that be? Well, we can divide by 20. So b to the 10th is equal to 2.5. How do you undo something raised to the 10th power? Well, you're going to use your root. So you're going to set up the 10th root of b to the 10th. Those are inverses of each other, so they're just going to cancel. And then you'll do the 10th root of 2.5. So we have b is equal to, depending on what calculator you're using, you're looking for the button that typically looks like this, and you want to put that as a 10. So like on a graphing calculator, like a TI-84 or something like that, if you press 10 and then look for the math button, all right, and if you press it, the fifth one typically is this right here. So when you press that, it'll rewrite it as 10, and it'll look like this, and then you can put 2.5 in there. And when you do that, you're going to get a number approximately equal to, because it's going to go on for a while, so approximately 1.09, and we'll round it to 6 there. So that's the multiplier. So what is the annual multiplier? That's this value right here. What is the annual percent of increase? Well, that multiplier includes the 100% that you start with. So you have 100%, and then you're going to add that percentage. So what is this number down here as a percent? Well, this would be 109.6%. So what did we have to add to the 100? We had to add 9.6%. So what is the annual percent increase? Then the annual percent increase, is going to be equal to approximately about 9.6%. And so that's one way to do it. Once again, there's all sorts of ways to do some of these problems. That's just kind of one way to approach it. Question 118. Larry started to set up a proof to show that if, looks like part of my thing got cut off right here. This is an A. So if line segment AB was perpendicular to DE, all right, that's given, and DE is the diameter of circle C, then we're trying to find that line segment AF is congruent to AF and FB. All right, examine his work, then complete his missing statement. So the first part is it's given. All right, that was the information given, that it was perpendicular, and that, where was it at? And is the diameter, DE is the diameter of that as well. Statement 2, angle AFC and BFC are right angles, and we know that because of the definition of perpendicular. Okay. Then FC's measure is equal to FC, and that is just saying that this segment is equal to itself, so that is the reflexive property, because it's the same one. And then we know that AC is equal to BC. So remember, this is the center. So AC is equal to BC. And we know that because of the definition of a circle. The radii must be equal. And then on 5, it's saying hypotenuse leg congruency. So we're trying to prove that those two triangles are congruent. So therefore, we can say that triangle AFC is congruent to triangle. So AFC would be BFC. And we know that by hypotenuse leg. You have your hypotenuse right here, and then the leg, which is right there. And then therefore AF is congruent to FB, and that's because of congruent triangles is going to imply that we also have congruent parts. So there are the reasons and the statements that we're missing for the proof. Question 119. Match each regular polygon named on the left with a statement about its qualities listed on the right. Let's start on the right-hand side. Maybe that'll give us a way we can find out some information. So the central angle is 36 degrees, so let's figure out how many sides it has. So we'll take 360 and divide it by 36, and that gives us a total of 10 sides. So we know B represents statement number 1, a regular decagon. Number 2, the exterior angle measure of 90 degrees. So the exterior measure is 90 degrees, which means that the interior would also be 90, or you could do the same thing that we did on the first statement, which take 360 divided by 90, which would be 4 sides, so that's a square, so D. Interior angle measure of 120, so the interior angle measure, which means the exterior, is equal to 60, so we can take 360 and divide by 60, and that would be 6 sides, so that would be a hexagon, so A would be 3. And process of elimination, we could say C is 4, but let's make sure. Exterior angle measure of 120, so since that's the exterior is add up to 360, so we'll take 360 divided by 120, and that will give us 3 sides, which would be the equilateral triangle, so statement 4 matches up with C. Question 120, examine the graph of f of x below. Use the graph to find the following values. So given the graph, remember when you have a point on the graph, for example, this point is 3, 5, the input value is 3 and the output is 5. So to answer part A, f of 1, the question is when x is 1, which is right here, all right, what is the output? So we go down to the graph. When x is 1, y is negative 3, so f of 1 is equal to negative 3. B, f of 0, so 0 is on the x-axis, go down here. That would be the y-intercept at 0, negative 4, so f of 0 is equal to negative 4. And then on the next two, it's going to give you the y value, or f of x, and you got to find x. So f of x is equal to 4, so on the y-axis now, when y is 4, what is the x values? And on this one, there's going to be 2 of them, and we'll have to approximate. It's pretty close to 3, but let's say, let's just go like 2.8, comma 4, and then over here, it's going to be negative 2.8, comma 4. So x would equal plus or minus 2.8. And then on D, f of x is equal to 0, so right here at 0, so it's going to be at negative 2 and 2. So x equals plus or minus 2. Question 121, examine the relationships that exist in the diagram below. Find the measures of angles A, B, C, and D. Remember that you can find the angles in any order depending on the angle relationship you use. So we have 2 parallel lines. We also have some triangles, some quadrilaterals it looks like as well. So let's just go ahead and start naming some things and see what we find. So if this angle is 112 degrees, then we know using straight angle that 180 minus 112 will give us that kind of third part of that triangle there. So that angle is 68 degrees. We also know that vertical angles are the same, so we can measure that one as 112, and then D would be 68, so let's go ahead and mark that one down. So D would be 68 degrees because it has the vertical angle with 68 across. Let's look at the parallel line. So we've got 2 parallel lines. The angle with 112 in C, that's same side interior, or we could do corresponding with the 68. So either way, 180 minus 112 is 68, or you can use corresponding angles to say C is 68 degrees. So what else do we know here? All right, let's go up to the 97 degrees. Here's another line that goes to the 2 parallel lines. So 97 and A are corresponding, so we know A is equal to 97 degrees. And then since we know A is 97, we can use the triangle angle sum theorem to take 180 minus 97 minus 68, and that will give us an angle measure for B to equal 15 degrees. And so therefore, all three of these angles right here will add up to 180. Question 122. How many cubes with edge length 1 unit would fit in a cube with edge length 3 units? So there's a couple different ways to look at this depending on kind of how much information you know. But if I create these, I could create, a cube kind of in the front here, and you could create 3 of them. So I'd go 3 across. You could also stack these 3 high. And then same thing back here, you would stack them 3 deep. And so therefore, you're going to have 3 by 3 by 3, which would be 27 1 by 1 cubes in a cube that has a length of 3 units.